Hi guys, we're back. This is Alana, Courtney, and Emmy. We're discussing the Littlefield simulation now, part 2. Okay, so the problem description. We are using Littlefield Technology Company. It's basically a very popularized system that is used in a lot of places. It's an online manufacturing simulator. The first thing that when you first started, it analyzes the first 50 days and shows you your money and the machines you have initially, and you can make changes to that. And then as you keep going, you progress, and you have the next 50 days, and you determine the optimal settings for Littlefield simulation, and comparing that with your SIMIO simulation, and you're trying to make sure that the SIMIO simulation is as closely representative of Littlefield. And then with the online simulation of Littlefield, it's a whole classroom experiment, and everybody's trying to compete with that with 50-day increments where we're making changes. Adjustments are made by each team, of course, and then class teams compete for the highest profit. And then here we have, so based on our SIMIO and SAS jump DOE results, we determined the best solution and what we should put into the Littlefield simulation. And we determined for Station 1 we should have 4 machines, Station 2, 2 machines, and Station 3, 2 as well. And then for the order types, we wanted first in, first out to minimize the work in process for them. Okay, so for the inventory policy, we wanted the reorder point to be 3,300, and the reorder quantity, we wanted 3,600.
So in Littlefield, this is a recap of our decisions made. On day 152, we had a total of 4 machines in Station 1, and on day 156, we had 2 machines at Station 3. So we bought machines there, and then also on day 156 we changed the reorder quantity to 3,600 and our reorder point to 3,000. Then on day 160 we changed to contract number 2 and then changed it again to contract 3 on day 168. And then on day 242 we changed the reorder points to 3,600 and then back down to 3,300 on day 250. And then on day 349, we sold a machine at Station 1, and then we bumped down to contract 2 on day 366. And so here are the results from Littlefield, starting with customer demand. Here's a plot of the numbers of jobs accepted each day. We were averaging about 11.7 jobs per day. This is important information because it helped us develop our EOQ model. It also could be important use for forecasting. And this information is also important because it shows us how volatile our customer demand is, which basically helps us in knowing how accurate our model is. And here are our results for machine 1. On the left here, it's a plot of our daily average number of kits queued for Station 1. You can see here in the graph around here that we purchased a new machine, which we did this because, as you can see in the graph, we were hitting 100% utilization. And then in the graph here on the right, it's a plot of the utilization of machine 1 averaged over each day. And in this graph, it shows that since we had machine utilization at 100%, we had bottlenecks there because we couldn't be doing any more with that. So we bought another machine to have a higher capacity because there was buildup in the queue of all the jobs we had. So buying another machine allowed us to have more capacity so we could meet demand better. And so for machine 1, over average for the entire thing, we ended up with a machine utilization of 64%.
And here's our information for machine 2. Once again, machine 2 has a plot of our daily average number of kits queued for Station 2, as well as our plot of utilization of Station 2 averaged over each day. What you can tell about this is we actually left machine 2 completely unchanged when it came to the number of machines. because our kits in queue were actually okay. They didn't need to be changed, and as you can tell on the right, our plot utilization for Station 2 is actually very good. We didn't get anywhere close to 100%, we got about to 85%. As you can tell on the bottom where it has a machine utilization of 46%. This is why we kept Machine 2 the same. Now on Machine 3, you can tell on the left-hand side, the plot of the daily average number of kits in queue, we had a lot of kits that ended up being in the queue because we only had one machine to start off with. At around day 156, we ended up buying a machine for Machine 3, which you can tell immediately made a drastic change for plot utilization of Station 3. We went from hitting 100% for about quite a long time for the first 150 days to really coming down and bringing it down to about 45% machine utilization. That worked really, really well because our queues weren't backed up, and it really reduced it, as you can tell on the left-hand side of the plot. So our inventory policy. Initially, we started off with a reorder point of 7,200 and a reorder quantity of 3,200. And what we did was when we started making our changes, we quickly found that our reorder points were a bit too high and we were carrying too much inventory. So when using the equations like our EOQ models, our ROP models, and we were able to figure out that we wanted to stay at about 3,000 units or kits, and we made that change at day 156, and our reorder quantity we bumped up a little bit to 3,600. For day 242, we found that we were actually ticking bottom a little too closely, and when the system was in a steady state, we were able to still do well and not miss any customer orders and have to give refunds, but there were a few points where we did 1 or 2 days, so we ended up making the change on day 242 where we changed over to 3,600, so our reorder point was a bit higher. That was a bit of a artistic move for us. And then day 250, we brought it right back down because we think we overshot just a little bit, so we brought it down to 3,300 reorder point.
Okay, so here when we're choosing the contracts, we mostly look at the lead times that we're having and the capacity in the machines. So when we were looking at the lead times, we saw that with each different contract, they had a one that they mentioned was optimal for that specific contract. And when we first started out with that first 50 days that we talked about earlier, we had contract 1. So when we were looking at our lead time as it was changing, we went ahead and switched to contract 2 to see what would happen, and we greatly reduced that lead time and maximized our revenue. And then after that, we saw that we were actually doing better than what we thought, and at day 168, we actually changed to contract 3. And from that, after we sold that one machine, we saw that we kind of dipped with contract 3, so we had to switch back to contract 2 just to stabilize it out.
So here's a plot of our revenues, for daily revenues. The black plot is for contract 1, which was a 7-day lead time, the maximum of 14 days. It unfortunately gave us a revenue of about $750 per job. When we ended up getting machine 1 and 3, we purchased on day 152 and 156, we saw we could be a bit more aggressive, especially considering that we started a little bit later. So we decided to go to contract 2, which saw our revenues increase to to 1,000, and then we ended up even being a bit more aggressive and staying at contract 3 for quite some time. Now we stayed at contract 3, as you can see there were some dips that kind of brought us below, but overall we averaged better on contract 3 than we would if we would have stayed at contract 2 for $250 less. And as Alana had stated before, when we did sell a machine for machine 1, we ended up having to switch back over to contract 2 just because we weren't hitting our lead times anymore.
So then lastly, we want to look back to our SIMIO model that we did in part 1 of this project. And so if you see here, we first look at machine utilization. And so in SIMIO, we had 59% for machine 1, 56% for machine 2, and 66% for machine 3. Whereas in Littlefield, we had 64 for machine 1, 46 for machine 2, and 45 for machine 3. And so looking at these numbers, you can say that it's a fairly accurate model. We definitely know that in hindsight, if we were to do Littlefield all over again, there would definitely be some things that we would do differently, with like starting at a different time, selling and buying machines differently. But that's just all in hindsight. Those are certain lessons that we've definitely learned through this project. And then the other thing we look at is throughput. And so in SIMIO, we had 33.42 kits per hour, and in Littlefield we had 29.17 kits per hour. So again, a fairly accurate model, definitely has a lot of room for improvement.
So now looking over to the overall standings. We really wanted to plot this graph on the left-hand side just to show that, for the first 150 days we had slowed down. We kept things steady, and then when we first got involved at about the 150th day, we bought 2 machines, which you can see in the dip in the graph on the left-hand side, and then we decided to be very, very aggressive. So the trajectory of our graph on the left-hand side was very, very good, and we believe that if we had started around day 50, we honestly probably could have been in first place or very, very close to the top. Though, as you can see on the right-hand side, we ended up becoming slowing down towards the end, so around day 350 when we made that one change and sold a machine 1, which in hindsight we find is a mistake. We ended up losing some of that revenue, but did not lose our place, so we ended up finishing 3rd in the overall standings.
So like Emmy just said, we did end in 3rd place. We definitely know that we made some mistakes, like starting too late, which made us have to make a very aggressive comeback, which we did. And then another mistake that we made was that we expected the simulation to end on day 350, so we sold machine 1 to try to make profits off of that. But that was our misunderstanding, so that was a mistake that we would probably do differently. But yeah, that wraps it all up. That is our part 2 of our SIMIO and Littlefield simulation. Thank you for watching.